We tend to split the world into two camps, math people and the rest of us. For most, staring at a page of equations feels like deciphering an alien language, an artificial chore invented to make school difficult. But if math is truly an unnatural invention, it raises a strange biological question. Why does the human brain devote highly specialized, energy-intensive hardware specifically to process it? The friction we feel occurs because we are forcing ancient biological hardware to run extremely complex cultural software. To see the hardware you were born with, we have to look at a reflex called subitizing. This is the brain's ability to instantly recognize the exact quantity of a small group of objects without counting them one by one. Let's test it right now. You have a fraction of a second. How many dots did you just see? You didn't count them. You couldn't have. There wasn't time. Your visual cortex processed the number 3 as a physical property of the image, in the same way you instantly recognize the color red. This reflex proves we don't enter the world as blank slates. Long before we ever learn what a number is, our brains are already wired with an active, biological baseline for mathematics. This instinct goes deep into our evolutionary past. If you're scanning a landscape for predators or evaluating a foraging spot, survival depends on a snap assessment of physical quantities. Scientists call this numerosity. It's an ancient neural mechanism designed strictly to judge more versus less in the wild, without getting bogged down in exact figures. We can trace this ability to a very specific fold of tissue called the intraparietal sulcus. Researchers observe intense activity in this exact region in infants, monkeys, and even crows. Every time you're presented with a physical quantity, this region fires automatically. It operates continuously in the background, acting as our biological estimation hard drive. Evaluating quantity is a primal reflex. Our ancestors relied on it to stay alive. But there is a serious limitation built into this neural hardware. As quantities grow beyond a handful of items, our internal estimation tool becomes incredibly fuzzy. Take these two clusters. One has 24 dots, the other has 25. Your intraparietal sulcus cannot tell them apart at a glance. The biological hardware simply taps out. You can't run a complex society on rough estimates. To track trade or build complex structures, humanity needed a level of precision our biology couldn't naturally provide. To bridge that gap, we engineered a workaround: written numerical symbols. Because we didn't evolve to read, there is no dedicated center in the brain for processing a character like the number 7. Instead, the brain is forced to hijack a series of entirely different neural networks. When you look at a symbol like 7, it first hits the visual cortex's pattern recognition circuits. It's then sent to the left hemisphere's language centers for a spoken name. Finally, a connection to the intraparietal sulcus anchors the abstract symbol to a physical magnitude. What we call a math brain is really just this forced, high-energy collaboration. 3 distinct regions of the brain rapidly volleying signals back and forth to make sense of a culturally invented code. This delicate neural relay explains why learning topics like algebra and calculus feels so exhausting. Abstract reasoning requires an immense cognitive tax. Every variable on a blueprint forces the brain to hold, translate, and manipulate symbols simultaneously. You are pushing a biological network originally built for counting berries to its absolute breaking point. That friction is the sensation of a primitive survival tool being stretched toward its structural limit. It is the effort of repurposing a berry counting circuit to solve for the unknown variables of our modern world. This shared biological foundation is what makes complex civilization possible. We are not born as effortless calculators, but we are all born with the primal hardware required to build them.